Good morning, students. Yesterday we have completed the 7th unit. So no student has come. So it is a okay. We are starting today unit 8. It is a system of linear equations. Okay. So in that, while I have told the introduction of all the topics in this 5th semester core linear algebra, I have told what are the linear homogeneous equations. Okay. So in that already you have seen in 2nd semester, that is a linear homogeneous equations are there. Okay. So in which you have if the equation it is equals to 0, then we call it as a homogeneous linear equation. So if we have here any constant values, then it is called as a non-homogeneous linear equation. Okay. So here, if the equations are like this, they are in the form of, we know that for any particular matrices will represent as A11, A12. It represents, it is the first row, first column. Second one is the first row, second column. Next, you will have the first row, third column. So we represent the elements as like this: A11, A12, A13, A14, up till we are taking the n elements. So A1n, xn. Okay. Here x are the unknowns. Okay. X are the unknowns here, and these are the elements we have in the matrix. So we'll write the matrices. No, A is equals to, that is Ax equals to 0. This will be in the form of Ax equals to 0. A is called as a quotient matrix, and X is the matrix of the unknowns or the variable matrix, and last whatever zeros are there, that zeros is called as a zero matrix. Okay. So if you see in the first unit, I have told it is the linear combination. Okay. So linear combination means here if you take these as a vectors, these are the here we are taking the scalars. The combination of these two and you're adding them. So it is equals to 0. Even it represents as a linearly independent solutions also. Okay. So whenever you're writing these in this form, last element is AM1, that is so on, whatever the in between will be there. AM2, X2 plus so on, AMN, Xn equals to 0. Here M represents the row, N represents the column here. So here, if you write this in the matrix form, it will be like this: A is equals to A1n, A21, 22, 2m, so on. It is M1, M2, so on, Mn. Okay. This particular A, whatever the quotients are there for the linear combination, we are taking them and writing as a matrix. It is equals to A11. And also, if you take the unknowns or the variables, it will be, that is capital X is equals to X1, X2, so on up till Xn. And here 0 matrix 0 is equals to 0, 0, 0, so on up till 0. Okay. If you will write the order of the matrices, this is M cross N. This is M cross 1. N cross 1. And this is M cross 1. Okay. So here, so only one column is there. Here also one column is there. If you write both means same, it will be there. So here we are writing N cross 1. That is N one column is there. N number of rows are there. Okay. Why? Because X1, X2, X3, X4, X5, X6. So here n number of rows and only one column. Here m number of rows. Same zeros are there, no? Those are n number of rows and one is the one column. And here m of rows and n of columns. Okay, this is the order of the matrices. Whatever it is there, homogeneous linear equation, we are writing in the matrix form. It is equals to Ax equals to 0. We'll write this as a equation Ax equals to 0, where A is, we call it as a coefficient matrix. Okay, I'm writing in a shortcut. Coefficient matrix. So here x is the variable and 0 is the zero matrix. So for this finding the homogeneous linear equations, we have the conditions are there. First thing is you will have the equations in this form. From that you have to write what is the coefficient matrix, what is the unknowns. This x, particular x is here, we call it as unknowns. Okay, means we have to find the values of x1, x2, x3 depending on the given problem. Okay, and here 0 means we are, after equating that equations, you will get the x1, x2, x3, so on up till xn values. So in our particular problem, only few variables will be given or few unknowns will be given. If 3 are given means we have to find the 3 values. If 4 are given means 4 values. Okay, so the working rule to find the homogeneous linear equation, we have some cases are there. So depending on those cases, we have to find the solutions of the given linear equations. Okay, so in that, first whatever the 3 equations are given means, first you write what is the quotient matrix and you see how many unknowns are there. So here unknowns are represented as, this is represented as small n. Okay, and also if you see, you will have small r. Okay, this small r equals to rank of matrix. Okay, small r is called as a rank of the matrix, and here number of unknowns means how many number of variables are present in that, that you will represent with a small n. Okay, so for this particular, to find the linear independent solutions and also solutions of the homogeneous linear equation, you have the conditions are there. So first thing is take the quotient matrix. After taking the quotient matrix, reduce it to the echelon form. Yesterday I have told the echelon form. So first reduce the given matrix to the echelon form and find the rank of the matrix. Okay, if you find the rank of the matrix, that means you are getting r value, and from the given problem you take what is the n. So how many unknowns are there in that? If you have 3, you can take the n value as 3. If you are getting the r value as 2 or 3, it depends on the given problem. So okay, so first case in that is, if r equals to n, means both n and r values both are same, then you will get 0 independent. That is, you have the formula to find the number of solutions is n minus r. Okay, n minus r solutions we have to find. So for that purpose, if you know n and r, if you substitute in this, both are same. If you are getting, means you will get n 3 minus 3 equals to 0. So you will get 0 linearly independent solutions. So if you get here 1, then you will tell it is the one linear, you are getting one linearly independent solution. Okay, so 3 minus 3 means 0, and the solutions will be in the form of, that is x1 equals to x2 equals to x3 equals to so on up till xn equals to 0 values you will get. Okay, when both are same, n and r are same, you will get 0, and here whatever the unknowns are there, that unknown values all you will get as 0. And second condition, here this is case when r equals to n, if r is less than n. Okay, so if you think r, you are getting 2 rank of the matrix, and also and number of unknowns is 3 you are getting. So if the problem wherever you are getting n and r values like this, in that conditions you can see that r n minus r, no, so you will get 3 minus 2, that is it is equals to 1. So one linearly independent solution you will get, and you will find that solution. What is that solution? You will find that one. Okay, this all conditions whatever I am telling now, those you have in your textbook. So if you have textbook, see page number 88. So in 88 page number, case first thing is, first to find the rank of the matrix, you have to reduce the given matrix to echelon form by using only row operations. Okay, elementary row operations only. And case one is r equals to n. The equation ax equals to 0 will have n minus n, that is 0 linearly independent solution, and the solutions are x1, x2, x3, so on, they are equal to 0. Okay. Case 2 is, if r is less than 1, then the equation will have n minus r linearly independent solutions, and you have infinitely many solutions. Okay, so it depends on the problem. Case 3 almost will not use in the problems. So for the homogeneous linear equation, we'll find one a problem. With the help of that, you can understand how to solve the given one. Okay. So you can see one problem here. That is, the linear equations are x minus 2y plus z minus w equals to 0, x plus y minus 2z plus 3w equals to 0, 4x plus y minus 5z and 5x minus 7y 2z minus w equals to 0. Okay, like this the equations will be given in your problem. Here 4 equations are there. Okay, so m represents the number of equations here. So m is the, here 4 equations are there, and if you see the unknowns are 1, 2, 3, 4. So 4 unknowns are there. Okay, so here if you see in the solution, so m equals to 4 and also n equals to 4 here. These are the unknowns. Okay, so to find, first we need the rank of the matrix. Okay, to find the rank of the matrix, we reduce the quotient matrix to echelon form. Okay, so for this one, first we are writing a. We need ax. The equation will be in the form of ax equals to 0. So here a is equals to, you write the quotients here, 1 minus 2, 1 minus 1, 1, 1 minus 2, 3, 4, 1 minus 5, 8, 5 minus 7, 2 minus 1. Okay, this is the quotient matrix A, and it is 4 rows are there and 4 columns are there. It is 4 by 4. Next, what you have, x, capital X is equals to, we have x, y, z and w. Okay, next 0 equals to 1. So this, now it is in the form of ax equals to 0 equation. So next procedure is, we have to reduce this whatever A matrix is there, that A matrix to echelon form. Okay, first thing is, in the echelon form, first element, first row, first column element, it should be 1. Already it is there in the problem. So no need of changing this one. Only this one, this second row, first element, third row, first element, and the fourth row, first element, you have to make them 0. Okay, so I am applying here the applications of the row operations. Okay, so that is R2, you are making it as R2 minus R1, next R3, R3 minus 4 R1, next R4, it is R4 minus 5 R1. Okay, so at the time we are applying the here 3 operations. Okay, so now that A will be converted to So A is, you can put like this. It is converted to first row. You keep like that only. -2, 1, -1. So 1 minus 1, it is 0. 1 minus of minus means it will be +3. Next -2 minus 1 means -3. 3 minus of minus means you will get here 4. Next 4 minus 4 is 0. 1 minus into minus is 4 to the 8. 8 plus 1 means you will get here 9. Next -5 minus 4. Okay. -4 means you will get here -9. Okay. Next 8 minus 4. Minus of minus is +4. 8 plus 4 means you will get here 12. And last one is 0. -7 minus 5 to the 10 plus 10. And this is 3. And next 2 minus 5 is -3. And -1, this is +5. Means you will get here 4. Okay. By applying the operations, we got this as like this. Now the thing is, you have to make this whole thing as 0. That is last, whatever the row is there, 4th row, you have to make it as 0. Before that, we can divide here whatever the row is there, 3rd row, R3 by 3. Okay. So this will be 1 minus 2, 1 minus 1, 0, 3, -3, 4, 0, 3, -3, and here this is 4, and 0, 3, -3, 4. Okay. This one, 1 minus 1, 0, 1 plus 2. So you will get 3. And here -2, -1, -3. -2, -1, -1. 0, 1. This is R2 minus R1. Minus of minus is +2. You will get 3 only. So if you'll see, this all are, you are getting the same one. Okay, that means these are 3 rows are identical. So you can make any 2 of them as zeros. So you can write here R. First thing is you make this one and this one. That is R3 is R3 minus R2. Next R4 is R4 minus R2. So you will get 1 minus 2, 1, 0, 3, -3, 4. 3 minus 3 is 0. -3 plus 3 is 0. Next 4 minus 4 is 0. Next 0. 3 minus 3 is 0. Next -3 plus 3 means 0. 4 minus 4 means 0. Okay. Here the 2 rows have been completed. So here 2 rows we have them as zeros. So only the non-zero rows are only 2. Okay. Equals to 2. Okay. Therefore, the rank of matrix is rank of the matrix R is equals to 2. Okay. So here we know N is equals to 4 and R equals to 2. So here we'll get, that is N minus R, no? N minus R equals to 4 minus 2 equals to 2 linearly independent solutions. Okay, two linearly independent solutions will get. So to get those two linearly independent solutions, first you construct here whatever the matrix A will be there, what are left with that, you write the equations. Okay, when you write the equations, you will write it as x minus 2y plus 3z minus w equals to 0, and next one is x is not there, so y 3y minus 3z plus 4w equals to 0. Okay, you can put them as 1 and 2. So to solve these problems, we assign here arbitrary constants. So here we assign arbitrary constants. So that is, we take here z value is equals to C1 and W is equals to C2. Okay, we need to find X, Y, Z values, no? So for that purpose, we are taking here. Why? Because from these equations, we can't get the values. So that's why we are taking the arbitrary constants as C1 and C2. Now substitute into what you'll get, 3y equals to equals to 0. So we need y value, that is 3y is equals to 3c1 minus 4c2, and y equals to 1 by 3 of 3c1 minus 4c2. So if 3 will get cancelled, it is c1 minus 4 by 3 c2. Okay, so we got y value. Same similarly, here we know what is z and what is w. We have to find the x value here. So for that purpose, you substitute x value, y value, z. Sorry, y value, z value.
One second.
Y, z, and w in 1. Okay, so when you substitute in this, you will get x minus 2y. Y is c1 minus 4 by 3 c2 plus 3z, means plus 3c1 minus c2 equals to 0. Okay, so now if you simplify this, you will get the x value, that is x minus 2c1 minus into minus plus 4 2s are 8 by 3 c2 plus 3c1 minus c2 equals to 0. So like this, you have to find the solution of the given problem. If you simplify that, you will get x minus 2c1. Here you simplify this. 3c1 minus 2c1 means you will get only 1c1. Next, 8 by 3 c2 minus c2 minus c2 means you will get it as 8 c2 minus 3 c2 by 3, that is 8 minus 3 means 5 by 3 c2, and even plus 5 by 3 c2 is equals to 0. So therefore x is equals to c1 minus 5 by 3 c2. So this is our x value. So like this, you have to find the x, y, z values, and even to check whether whatever the values you have got, x, y, z, and w, if they satisfy the first linear equation, then you can understand that the whatever the values you are getting, that are the correct values. Okay, so what is the first linear equation given? It is x minus 2y plus 3z minus w equals to 0. So x value is c1 minus 5 by 3 c2 minus 2y. What we got? Y minus 2y. Y is this one, that is 2c1 minus 4 2s are 8 by 3 c2 plus 3z means plus 3c1 minus W C2. So you have to get it as 0, no? C1 minus, this is 3, 4. 4 means okay. So here we can write, so it will take lengthy process. So therefore you keep x equals to C1 minus 5 by 3 C2 and y equals to C1 minus 4 by 3 C2 and here z equals to C1 and w equals to C2. Okay, these are the solutions of the given problem. Okay, whatever the steps are there, you see in your textbook and you write all those steps. Okay, here we have to write x value, y value, z and w values constitute the general solution of the given system of equations. Here constitute the general solution of given equations. Okay, so like this is the procedure for all problems. Any problems, if you are getting n minus r value as something, if n, that is r value is less than 1, you will get the solutions like this. If you get r and n values are both are same, means you will get x1, x2, x3, those so on values as zeros. Okay, so example problems are there in your textbook, so try to solve those and practice those problems. I'm not telling r equals to n1. If you see that problem, so in that case, you, if both r and n are same, then you will get that as a, means x1, x2, x3 values as zeros. If you see that you have in your page number 89, 8.2.2, 8.2.3. So these are the example problems. Okay, so try to solve them. Next, this is the procedure of finding the linear homogeneous equation. Next we have system of, that is a non-homogeneous linear equation. So in this, just the same will be there. You will have like this: a21, x2, so on up till equals to b1. Okay, instead of 0, you will have one more value there: 21 x1 plus 22 x2, so on up till 2n xn equals to b2. Okay, so like this, if we have b1, b2, b3 all values, then it is called as a non-homogeneous linear equation. Here we are getting the value. So this will be in the form of like this: ax equals to b, where a is the quotient matrix, x is the matrix of unknowns, and b is the matrix of all the constant values, whatever you have on the right hand side of that one. So here we'll write a as a11, a12, so on up till a1n, a21, a22, so on 2n. So this will be m cross n, and x will be here x1, x2, so on up till xn, and b is equals to b1, b2, so on up till bn. Okay, so here the equation of this non-homogeneous linear equation will be in the form of ax equals to b. Okay, so same, to find the solutions of the given linear equations, we'll have the working rule is there, cases are there. So in that, when you will get the solutions, so the conditions are there, So for that one, first one is we'll find the A, whatever A is there. That A we call, already we know that it is a quotient matrix. So we'll find the rank of A. So rank of A we represent as R here. Okay. So and we know the combination of A and B. If you put like this is called as augmented matrix. This is called as augmented matrix AB. That is A and B we are combining. The combination of A and B is called as augmented matrix, and the rank of AB. Okay. So here we know that it will be represented with small r. Here rank of AB we are not representing with any particular number. Here we consider the cases. What are the solutions of the problems? To solve that one, we will use rank of A and rank of AB. Similarly, for the homogeneous equations, how we have like that only if rank of A is equals to rank of AB. If both are same, no, then you will have zero solutions, because both are same means no solution will be there. And also that means you can tell here you will get as one unique solution. Okay. So when this case is satisfied, you will get one unique solution. Okay. So when rank of A equals to rank of AB, if rank of A is less than rank of AB, okay, that means if this value is smaller than whatever AB is there, then in that case you will get infinitely many solutions. Okay. And also one more point we have here. If rank of A is equals to rank of AB, the solution is you have one unique solution, and this is called as consistent solution. You will see in problems, you will find this one. Okay, this type of whatever the solution is there, when rank of A equals to rank of A, we call it as consistent equation. Okay. If rank of A equals to rank of B, consistent, and if this is less than, we call it as inconsistent. These two words you can see in your textbook. Show that the given equations are consistent, or whether you'll have the show that the equations are inconsistent. So if to satisfy this one, this is the condition. To satisfy this one, this is the condition. So similarly, if both R is equals to, that is rank of A equals to rank of AB, we'll get a unique solution, one solution. If rank of A is less than rank of AB, so in this also same cases you will arise R equals to N, R equals to less than N. So for this one, you will have, when both are equal, you will get no solution. So when R is less than N, you will get infinitely many solutions. Infinite solutions you can take. Okay. Infinite solution. These are all working rules you have in your textbook. So to solve the problem, we have to follow them. In page number 92, you have case one is, that is rank of A is less than rank of AB. Then equation AX equals to B are inconsistent. That is the given equations have no solution. Okay. And second case is rank of A equals to rank of AB equals to, or both are same. Okay. Then the given system is called as consistent and possess N minus R linearly independent solutions. Okay. N minus R means if you got N value as 4 and R value as 3, you will get one linearly independent solutions. Okay. Similarly, continuation of case 2, you have the same one. That is when R and N are both are same, one unique solution you will get. If R is less than 1, you get infinite number of solutions. Okay. We'll see one example problem on this. See, first problem is like these three equations are given. So these three equations, first you write them in the form of Ax equals to B here. So we can convert them as like this: 2x minus y plus 3z equals to 9. And this is x plus y plus z equals to 6. And this is x minus y plus z equals to 2. Okay. So now we have to write them in the form of Ax equals to B. So here our A is 2 minus 1, 3, 1, 1, 1, 1 minus 1, 1. Okay. And here our x is x, y, z, and B is here 9, 6, 2. Okay. So here the augmented matrix AB is equals to 2 minus 1, 3, and here 9. Next 1, 1, 1, 1 minus 1, 1. Here 6, here 2. Okay, this is called as augmented matrix. This is A and this is B. Now you have to reduce this one. Okay, you have to reduce this matrix to echelon form and you have to find the rank of the matrix. Okay, so for this one, you apply the row operations. So we can apply here. First thing is here 2 is there. To make it as a 1, just to interchange that one. That is R1. R1 you are interchanging as R2. So you will get it as 1, 1, 1, 6, 2 minus 1, 3, 9, 1 minus 1, 1, 2. Okay. Now you have to make this as 0, this whole thing as to 0. Okay. Or else if possible, they may become 0 or you may not get. Okay. So next here R2 is R2 minus 2 R1. Next R3 is R3 minus R1. So it will be 1, 1, 1, 6. 2 minus 2 is 0. Minus 1 minus 2 is minus 3. 3 minus 2. 1. Next 6 minus 12. We'll get it as minus 3. Next R3. Minus 1 minus 1. Minus 2. Next 1 minus 1 is 0. 2 minus 6 is minus 4. Okay. So here next thing is, if possible, you can make this as 0. See here 0, 0, 0 is there. So if you do again subtraction of this one, minus 2, this one minus 3. So you will get here again same element. Or else only you can make here 0. Again you will get 1 here. 1 plus 0, no, same element you will get. So here the third row, whatever it is there, it is not vanishing. Okay, it is not, we are unable to make it as zeros. So here we can say that the rank of AB is 3. Okay, so whatever the rank is there, the rank of AB is 3. Or else if you want to make minus 2 and 0 means this minus this, R3. What you can do, R3 minus 2 by 3 we can do, no? C2. Just to actually the rank is same 3 only. Just to make this element as 0, we can do R3 minus 2 by 3 C2. Then what you will get? 1, 1, 1, 6, 0, minus 3 you put like that only. Okay. 1, 6. Next last one 0, minus 0, minus 2, Here what we have taken minus 2 by 3. That is minus 2. Minus into minus is plus 3 into 2 by 3. Okay. This is R2. So 3 will get cancelled. Minus 2 plus 2 means this will be 0. Next what we have 0 minus 2 by 3. That is minus 2 by 3. Next minus 4. Minus into minus is plus into 2 by 3. So 3 will get cancelled. Minus 4 plus 2 means we get it as minus 2. See, now also we got 3 non-zero rows. If you just change, so echelon form means this triangle, whatever it is there, it should be 0, no? So to convert that one, just we have changed that one. Okay. So 1 0 0 0. Here the number of non-zero rows are 1 2 3. So rank of AB is 3, and also this whole thing is AB. If you'll see only this A, here also we got 1 2 3 non-zero rows. So rank of A is 3 and rank of AB augmented matrix is also 3. So we got here rank of A equals to rank of AB. So it is a constituted equation. So rank of A equals to 3 and the rank of AB equals to 3. So that means here rank of A is equals to 3 equals to rank of AB. So we'll get the no solution. So here the equation is consistent. Okay, but because both are same, and here the number of unknowns are equals to, that is n is equals to 3, x y z, no? So n is equals to 3 and here r equals to 3. So means n minus r is equals to 3 minus 3 equals to, that is 0. You will get only unique solution. We get unique solution. Okay. So when we get the, and we have to find what is that unique solution. So for that we'll write the matrix as, that is A you take out, and you take out what is B and what is X. Okay. So you write here, write the matrix equation as now separate A, that is 1 1 1 0 minus 3 1 0 0 minus 2 by 3. What is our X? X is equals to X Y Z, and what is our B? B is equals to 6 minus 3 minus 2. Okay, this is our equation. Now you write the equations as that is X plus Y plus Z is equals to, here we have 6. Next, this is X, this is Y, that is minus 3Y plus Z is equals to minus 3. And last one is minus 2 by 3, Z is equals to minus 2. So from these equations, we have to find X, Y, Z values. Okay. So here minus 2 and minus 2, if both will get cancelled, then Z will be 3. You can put this as equation 1 and equation 2. So substitute Z equals to 3 into, what you get, minus 3y plus 3 equals to minus 3, implies minus 3y equals to 6, y equals to minus 2. Okay. minus 6 now this is. So plus if it will go that it is a minus, so minus 6, both minus minus will get cancelled, y equals to 2 here. So next substitute z and y in 1. So z and y in 1 means x plus 2 plus 3 equals to 6, implies x equals to 1 you will get. Okay. So therefore the solution, only unique means only one solution. So here the solution is x equals to 1, y equals to 2 and z equals to 3. So this is the solution of the non-homogeneous linear equation. So first thing is you have to reduce the AB augmented matrix to the echelon form and we have to find the rank of the matrix. If the rank of, so from reducing AB augmented matrix only easily we can see what is the rank of the matrix A and also rank of the matrix AB, that is the augmented matrix. In this case you will get both are equal. In some cases you may get rank of A is 2 by 2 matrix. If all the whatever here, if it is also becoming 0. So what will happen? The row, only 2 rows are left. Third row, it has become all zeros. So the rank of A is 2, but the rank of AB will be 3. In some problem, it will be there. Okay. So when you reduce this whole row to 0, the rank of A will be 2, but the rank of AB will be 3. So in that case, R is less than, that is rank of A is less than rank of AB. So in that case, it is the inconstant equation and you will get the infinite number of solutions. So for that also we have to find x, y, z values. Okay. So that example problems you have in your textbook, page number 94 we have, and also page number 95. In that case, A and AB are not same. Okay. So if A and AB are not same means you will get the given equation will have 3 minus 2. The number of unknowns are 3. So 3 minus rank is 2. You will get one solution. Then you can find the solutions x, y, z. Okay. So these are the important problems you have in system of linear equations. So one problem you will get on homogeneous equation. And also you may have a 5 marks question almost you will get. Only the inconsistent problem is there, no? So these non-homogeneous linear equations you may get for 10 marks. So homogeneous only for 5 marks you will get. Next we'll go to the unit 9. It is the characteristic roots and characteristic vectors. Characteristic roots and characteristic vectors and Cayley-Hamilton theorem. Okay. And characteristic vectors. Next we have Cayley-Hamilton theorem. Okay. So almost if you see one example of any matrices, in that only we can find what are the characteristic roots and characteristic vectors. Okay. So here characteristic roots means before that we have the concept of characteristic equation. Okay. Okay, characteristic equation means first thing is whatever the quotient matrix is there, that will represent as A minus, if we'll take here lambda is any indeterminate. Okay, lambda is any indeterminate. Here A is the quotient matrix and we are doing that is A minus lambda of I. Okay, A minus lambda of I. And if you are taking the mod of this, or we call it as a determinant of A minus lambda I equals to 0. This is called as a characteristic equation of the given matrix. This is the quotient matrix. Lambda is any indeterminate and I is the identity matrix here. So if you take any A matrix as A11, 1, 2, 1, 3 up till A1n, next to 2, 1, 2, 2, 2, 3 up till 2n, next so on like this. And here if you do the, this is the matrix A, no, I will take, it depends on the give, whatever the quotient matrix is there, it depends on that matrix. If you will write this one A minus lambda I, that is a determinant of A minus lambda I, means you will get it as mod of A11 minus lambda 1n, next A21, next A22 minus lambda, so on A2n. So here you will get A33 minus lambda, so on A3n. So like this. So A M1, M2, so on A Mn minus lambda. This is equals to 0. So if you equate the determinant of this one equals to 0, it is called as a characteristic equation. Okay. So it will be in the form of a polynomial. When you take out, when you do the find the determinant of that one, you will get one polynomial. So when you equate it to 0, we'll find the roots, no? So that roots are called as a characteristic roots. Okay. So you get one polynomial in the lambda. So when you find we'll do the factorization, and when you find that lambda values that are called as a characteristic roots or eigenroots or eigenvalues or characteristic values. So both these three are same only. Characteristic means in some problems they may ask it has a characteristic roots, or in some question they ask eigenvalues, or in some cases they will ask characteristic values. So three are same. And also here we can tell the definition as the roots of characteristic equation are the roots of A minus lambda I equals to 0 are called characteristic roots or eigenvalues or characteristic values. Okay, this is the definition of characteristic roots. From this only, what is characteristic vectors? Okay, so characteristic vectors means here you will get here lambda values, no? So depending on that, if you have the power as 3, you will get 3 roots. If you have a power as 2, you will get the 2 roots. So it depends on the whatever the power is there in the polynomial. So whatever the polynomial you will get, when you will do the determinant of that one, that many roots you will get. So whatever the lambda values are there, if you substitute that lambda values in this characteristic equation, then you will get the some other values. Okay, so that values are called as a characteristic vectors or eigenvectors. Okay, so characteristic vectors or eigenvectors means whatever the characteristic roots you are getting in the problem, if you substitute them in the characteristic equation, you will get some other solutions that are called as characteristic vectors. So the equation will be like this. Ax equals to that means Ax equals to lambda x. You will get the equation like this. In this, whatever the values you are getting, that are the characteristic vectors we call are eigenvectors. So problems will be asked. So these are the 5 marks problems. Only characteristic roots means you will get 5 marks problems whenever it is a characteristic vectors, because you are doing the 2 methods in this one. First thing is we are finding this characteristic roots. Next we are finding the vectors. So you will get this type of problems for 10 marks questions. Okay. So eigenvectors are eigenvalues. So we'll see one example. With that you can tell easily, you can understand what are the characteristic roots and characteristic vectors. Here is given that A equals to 1, 1, 3, 5, 2, 6. So for this you are not getting the values. Another problem is 1, 4, minus 3, 0, 3, 0. Okay. Find characteristic roots. Okay, this is the A, it is given. So first thing is we have to find the characteristic equation, that is A minus lambda I. So A minus lambda I means here A is 1, 4, minus 3, 0, 3, 0, 0, 2, minus 1, minus lambda into I. This I is a identity matrix. So identity matrix depend on the number of rows and columns present in the given matrix. So here the number of rows are 3 and also number of columns also 3. So it is a 3 by 3 matrix. So we'll write here 3 by 3 identity matrix like this. Okay, direct procedure also we can do, or else you can write like this and you can write first. If you don't put the determinant here, when you write like this, it will be, this is 1 minus lambda. Here you will get minus lambda, minus lambda, minus lambda. That means 1, 4, minus 3, 0, 3, 0, 0, 2, minus 1, minus, if you will take, it is minus lambda 0, 0, 0, minus lambda 0, 0, 0, lambda. So we'll get it as 1 minus lambda, other are 0. So 4 minus 0 is 4, minus 3 minus 0 is minus 3, here 0, next we have 3 minus lambda, next 0, next 0, 2 minus 0, here we'll get minus 1 minus lambda. Okay, so if you, so this is the method of directly we can write actually only whatever this diagonal is there here. Okay, this only diagonal you will get all the lambda values, that is 1 minus lambda, 3 minus lambda, minus 1 minus lambda. So no need of doing all this procedure, just for your understanding I have told this one. Okay, so like this we have to find the A minus lambda I. So now you can take it as, that is a determinant, the characteristic equation determinant of A minus lambda equals to 1 minus lambda 4 minus 3 0, 3 minus lambda 0, 0, 2 minus 1 minus lambda. Okay, this is equals to 0. Okay, so this is the characteristic equation, that is A minus lambda I equals to 0. So now you do find the determinant of this one. This is 1 minus lambda. So we eliminate row and column, you will get it as 3 minus lambda into minus 1 minus lambda. This is 0. So only one value you will get. Next, if you see minus 4 into, if you eliminate this row, 0 into this one, 0 into this one. So 0 minus 3 into 0 into 0, this is 0 equals to 0 here. So only this part we have to do the simplification. So 1 minus lambda into minus 3, 3 minus 3 lambda, minus into minus plus lambda, minus into minus plus lambda square equals to 0. Okay, so 1 minus lambda into lambda square minus 2 lambda minus 3 equals to 0. So what you get here? So with 1 you multiply lambda square minus 2 lambda minus 3. After that minus lambda cube minus into minus plus 2 lambda square. Next minus into minus plus 3 lambda. Okay. So highest power is here. This is minus lambda cube. So lambda square plus 2 lambda square is 3 lambda square. Minus 2 lambda plus 3 lambda means we'll get here plus lambda minus 3 equals to 0. If we take out minus common, 3 lambda cube minus 3 lambda square minus lambda plus 3 equals to 0. Okay, this is the, we got the polynomial. Okay, we got the polynomial as this one. Now we have to find the roots of this polynomial. So with the help of the division rule we have now, with the help of that, if you will find, you will get this as lambda minus 1, lambda plus 1, and also lambda minus 3. Okay, this I hope so you know how to find the factors of this one. So whenever lambda cube is there, with the help of the division rule, you find that one. So you will get this one as lambda minus 1, lambda plus 1, lambda minus 3 equals to 0. So you will get the lambda values as, that is lambda minus 1 equals to 0 means you will get 1, and this is minus 1 and this is 3. Or else you can write it as first write negative value, this one. So here whatever we got the lambda values minus 1, 1, 3, these are called as a characteristic roots. Or eigen values or characteristic values, anything. In the given question, whatever you have, you can write that one. So whatever this lambda values you are getting, minus 1, 1, 3, this if you substitute in this equation, okay, that means determinant of a minus lambda I, if you will take, you have to do, you will get 3 eigen vectors. Okay, 3 eigen vectors you will get. Why? Because we got here lambda value as 3 roots we got. So first case you have to write here lambda value as minus 1, and you have to solve the whatever the matrix is there, that you will get the solution. So second case you have to find when lambda equals to 1, and third case when you substitute lambda equals to 3, you get one more eigen vector. So you will get the 3 eigen vectors for the 3 eigen values. Okay, that is the procedure when you will find for lambda values. Okay, so that will be the lengthy process. So tomorrow, if I have the time, I will tell this one even eigen vectors also. So or else you have the example problem in your textbook, page number 99. You have see. It is a determine the characteristic roots and the corresponding characteristic vectors of the matrix. Okay, so whatever the matrix is there, for that matrix, first we are finding the lambda values. We got here lambda equals to 2, 2, 8. Here 2 are same values. Vectors, whatever the roots we are getting eigen vectors that are same. So if you find eigen vector for any one value, it's enough. Why? Because both are same, no? So at lambda equals to 2, if you find, it is the value for the 2 values. So first take lambda equals to 2 and you find the eigen vectors. And next one is when you take lambda equals to 8, you will get one more eigen vectors. So you will get the 2 eigen vectors here. So try to practice the problem, whatever you have in your page number 100. Okay. So next we have Cayley-Hamilton theorem. So 10 marks question compulsory you will get from this. It is the Cayley-Hamilton theorem. So he will ask the verification, that is a state and prove the Cayley-Hamilton theorem. Cayley-Hamilton theorem. So this statement is every square matrix satisfies its characteristic equation. Every square matrix so Cayley-Hamilton theorem statement is every square matrix satisfies its characteristic equation. So every square matrix means either whether it may be 2 by 2 square matrix or 3 by 3 or 4 by 3, any square matrix satisfies its characteristic equation. So the characteristic equation is A minus delta I equals to 0. So whatever the square matrices is there, it satisfies the characteristic equation. This whatever statement is there, that you have to do. You have to do with the help of the proof. Okay, and you have to show that here whatever the statement given in the theorem is there, that is the correct one and it is satisfying the conditions here. Okay, so for this purpose we will take A minus lambda I. Just before the definition of characteristic equation I have given, no, that A11 minus lambda A12 up till A1n and A21 A22 minus lambda A2n and also A mn, m1, m2. Last you will get A mn minus lambda. So that whatever the equation is there of the characteristic equation, if you do the determinant of that, you will get the quadratic polynomial here. Any polynomial you will get, that polynomial, it satisfies the square matrix. So that you have to show that proof you have in your textbook. So tomorrow, if we have time, we'll not tomorrow, no, next week. So you have the proof of Cayley-Hamilton theorem on page number 101. So I hope you have textbooks. Proof you see, it is 101 page number you have. So verification of Cayley-Hamilton theorem will be there. They may ask the theorem for 10 marks or else they will ask the verification of the Cayley-Hamilton theorem for 10 marks. Any one you will get for the 10 marks, but 10 marks problem is a compulsory from 9th unit. Okay. So try to practice the theorem. So next week, I hope so, new schedule has come. So in that they have added more 2 classes for the 5th semester course. So next 19 and 20 you have for the 5th semester course only. After that, whatever the next we have Saturday and Sunday, that you have for the elective. Okay. So last 2 classes are there. On that we'll cover the problems on Cayley-Hamilton theorem. Next we'll go to the block 4. It is a quadratic forms and inner product spaces. Okay. So quadratic form you will get for only 5 marks. But whatever the other are there, inner product space are there. And also Gram-Schmidt orthogonalization process is there. That is the 10 marks question. Okay. So last 2 units, that is 11th and 12th unit are 10 marks. And only 10th unit you have for 5 marks question. Okay. So next 2 classes we'll try to complete the 4th block also.